Hi guys, today we're going to cover section 2.3, the linear function and slope. This should be a fairly straightforward section because we've been talking about slope for probably last 3 semesters. So if you have been a student at GRCC, that means we start talking about slope in Math 98, 107, and now 110. So it should be a pretty straightforward topic and not too many tricks. Okay, so let's go ahead and get started. Just really quick, slope. Right, if you look at the definition that most people are familiar with is the m equal y2 minus y1 over x2 minus x1, where x1, y1, and x2, y2, those are points on the line. Then the second part is the slope is also known as rate of change. Okay, a rate of change, which means typically it's a fraction with a quantity on the top and a quantity on the bottom. Okay, and this is more used when it comes to story problems where there are labels for the top and bottom. Okay. Now, part C, when it says the average rate of change, what they're saying in this case is now, because we're dealing with a linear function, so the average rate of change, it's basically this. Okay? But in case when we have a function that is not a straight line, so for example, it looks something like this, and we're looking for point A and point B, the average rate of change between point A and point B will be the slope of the straight line that goes through point A and B. Okay, that's why this is called the average rate of change. That's if our graph is not linear. Okay, and we'll talk about the reasoning behind the slope of vertical horizontal line and also the parallel perpendicular line. Alright, let's go ahead and get started. For number 2, A, B, and C, we're just going to go ahead and find the slope. So if we're given 2 points, we're just going to use the formula. Okay, so for part A, you have 2, 7, and 5, negative 4. Now, just in case you forget, it does not matter which one you call it, x1, y1, or x2, y2. You just need to make sure you are consistent. Okay, consistency is key in this case. So if you call this x1 and this x2, that means this has to be y1 and y2. Okay, or if you call this x1 and this x2, that means the number negative 4 has to be y2, the number 7 has to be y1. Okay, it does not matter which one you go with, you just gotta pick one. Okay, so for part A, the slope is going to be, I'm gonna use the x1, this set. So you have negative 4 minus 7 over 5 miness 2, and this is just negative 11 over 3, and then we're done. Okay, so the slope of the line that goes through the points 2, 7, and 5, negative 4, it's going to be negative 11 and 3. Excuse me, negative 11 over 3. Okay, so part B, same idea. You got 10, negative 3, negative 2, negative 3. Okay, so go ahead and use our formula. You got negative 3 minus a negative 3. Be careful on the minus sign. And you have negative 2 minus 10. Okay, so you're not getting 0 on top and then negative 12 on the bottom. So the slope in this case is 0. Okay, and now, if you look at the points, right? notice these 2 points have the same y value. So that means graphically, one is 10 over and -3 down. The other one is -2, so 2 to the left, and then -3 and 3 down. Okay, so in this case, if you look at it, if you connect the dots, you have a horizontal line. The horizontal line has the slope equal 0, because if you use a slope formula, you end up getting a 0 for your slope, right? The y value will cancel each other out, so leave you with a 0 on the top. Okay. And the next problem, -5, 9, and the -5, -2. And I'm sure by this time you're probably looking for some patterns. And there is indeed a pattern. -2 minus 9 over -5 minus the -5. You get -11 on the top. You get 0 on the bottom. This means 0 on the bottom is bad. This is undefined. Okay. And if you graph it, the points, you have -5 and 9. So here's -5, here's 9, so somewhere up here. And you got -5, -2. So -2 is over here. So you got another point somewhere over here. When you connect them, you get a vertical line. Okay, and this is the reason why vertical line, you end up getting slope with a 0 on the bottom, and therefore it is undefined. Okay, slope of a vertical line is undefined. Slope of the horizontal line is equal to 0. Alright? So this is how I actually remember it. There might be a different way to do it, but if you have a different way of remembering, be my guest. All I care about is if you know how to figure it out and how to reason it out, especially. Okay. All right, let's look at the next set of questions. Let's see. There we go. Next page. Find the slope of the line by first finding 2 points on the line, then use the slope formula. So, y minus 2 equal -3x minus 5. Okay. In this case, we're going to have to use the table. So, alright, so typically, a lot of times we're kind of used to use 0, 1, 2, 3. Okay, that's not always going to be a good thing, but in this case, because there are no fractions, so we're okay. If there are some fractions within the numbers, I will probably reconsider using 0, 1, 2, 3. I won't use it until I figure out what's going on with the fraction and how that will affect my answers. Alright, so plug in 0 for x. You get y minus 2 equal -3 times 0 minus 5. So this is y minus 2 equal -3 times -5, which is y minus 2 is 15. So y is 17. Okay. Plugging x equal to 1, you get y minus 2 equal -3 times 1 minus 5. Y minus 2 equal -3 times -4. So y minus 2 is 12, and y is 14. Okay, I got my 2 points. I'm just going to go ahead and use my slope formula. So I have slope equal 17 minus 14, 0 minus 1. Right? 17 minus 14, 0 minus 1. I'm consistent. This is 3 over -1, and that is my slope. Okay, my slope right there. Okay. Yeah, unfortunately, if you're gonna need a couple points, we're gonna need a table. So if you don't like tables, start liking them again. Okay. 3x minus 7y equal 21 is our second question. Alright. Gonna use some old tricks here. 0 definitely works. But if you remember from your previous classes, we can put in 0 for x or y. And I'm gonna do that because hopefully by this time you should recognize that this is a standard form, and then it's much easier to plug in zeros. So here we go. If x equal to 0, you get 3 times 0 minus 7y equal 21. This is the same as negative 7y equal 21. So y is negative 3. Right? After you divide by negative 7 on both sides. Now, plug in 0 for y. You get 3x minus 7 times 0 equal 21. This is 3x, that's 0, equal 21. So x equals 7. Okay. So our slope is going to be negative 3 minus 0 over 0 minus 7, which is negative 3 over negative 7, or 3 over 7. Okay. Pretty straightforward. Alright. Now next one, we're kind of giving you a little bit more curveball on the problem. Notice this time we're just going to have letters all over the place. Okay. So in this case, I'll tell you the things that I'm looking for. Notice I'm going to put 0 for x because usually that's pretty easy to use. But this time, for the y, we got a couple choices. We can either pick 0 or pick 5. Okay, it doesn't matter which one you pick. You can either pick 0 or 5. The reason I would pick 5 is because if I put 5 in here, 5 minus 5 is 0. Okay, so it'll make things a little easier, but it's totally your pick. Okay, based on the question. Alright, but I'm just going to go ahead and pick 5. Okay, so now let's go ahead and find out our what happens when x equals to 0. So you get 2 times y minus 5 equals 0 plus 2y. So this is 2y minus 10 equals 0 plus 2y. Okay, so what we end up getting is negative 10 equals 0. Uh-oh. What does that mean? Alright, so check this out. Right? So if you get, in this case, we're getting, when we plug in 0 for x, we get something that's false. Okay, so what does that mean? This means this line will never ever cross the y-axis. Right? Because what happens what's the x value when you're sitting on the y-axis? When you're sitting on the y-axis, the x value is always 0. Okay? So if I plug in 0, I get a false result. This means never cross y-axis. Okay? And the only way that we're going to have a line that does not cross the y-axis is it has to be a vertical line of some sort. Because if you have a horizontal line will always cross the x-axis. The y-axis. Excuse me, misspoke. If you have a line that's diagonal, you will still cross the y-axis. Okay, so the only way that when x does not equal to 0, when the x equals to 0, when y is false, it has to be a vertical line. And which means when you got a vertical line, the slope is undefined. Okay, so there's but there are a couple different ways you can do this. But unfortunately, 0 false, that kind of throw us for a loop. Okay, we're gonna have a little bit of reasoning skills to figure this out, but it's all right. Or you can just pick a different number for x and see what happens. Okay, there we go. So number 4. Yeah, I do like slope. Slope seems to be a pretty easy concept, but there are definitely some trickeries that's in there that we just gotta kind of spend some time and think it out. Okay. Number 4, determine if the pair of lines are parallel, perpendicular, or neither. Okay, so these are a couple of things you gotta remember. So if you got lines that are parallel to each other, so I'm gonna use my symbol, just because I don't want to write so many times. The slope are the same. So if two lines are parallel, they have to have the same slope. Okay. And then the lines that are perpendicular, notice the little right triangle symbol. The product of the slope is -1. So that means either, there's a couple of different ways to show this. Either they say that m1 times m2 equal -1, or m1 equal -1 over m2. Most people like this way better because this is the opposite reciprocal that we hear mostly. Okay, most of the time when you hear about perpendicular lines, the teacher usually say the slopes are opposite reciprocal. Opposite sign. And reciprocal. Right? So you can remember either this way or this way. I don't care which way you use it. Idea is the same. Okay? So keep that in mind. So let's go ahead and work on the number 4, part A. Number 4, part A says we have a line that goes through 517 and 1717. And we have another line that goes through -7, -14, and 2, -14. I'm hoping by this time, right, you should be able to recognize this, that if the y values are the same, you have a horizontal line, which means the slope is equal to 0. Okay, so same thing here. They are the same, -14 and -14. So this is a horizontal line, and where slope is equal to 0. And therefore this matches our parallel idea. Slopes are the same. These two lines are parallel. Okay. Now, sidebar. There are sometimes that where two lines have the same slope, but they're not parallel, because overlap. Okay, two lines could be exactly the same, right? Which means they lay on top of each other, and they'll both have the same slope. But if two lines are on top of each other, that means they're not parallel, because parallel by definition, right? If you think about parallel, the lines cannot touch. So we gotta kind of think about what's going on. Okay. And in this case, notice they have different values, so 17 and negative 14. So there's no way they're touching. So that's why these are parallel lines. Okay. All right, part B. A line goes through negative 4, 3, and negative 4, negative 3. And the other line goes through negative 2, 1, negative 5, negative 3. Okay. All right. Well, looks like this one is the one we need to do a little bit of work. So let's figure this out. So slope is going to be negative 3 minus a positive 3 over negative 4 minus a negative 4. Okay. So this right here, what we have is negative 6 over 0, which is a undefined. Okay. Now for part B, you have negative 3 minus 1, negative 5 minus a negative 2. This is negative 4 over negative 3, which is 4 over 3. Okay. So once you figure out slope, visually you can check. Negative 6 over 0 is not equal to 4 over 3. So therefore, cannot be parallel. Okay. The reciprocal, I don't care which one you pick, of negative 6 over 0 is 0 over 6. And 0 over 6 is not 4 over 3. Therefore, this one is not parallel either. Sorry, not perpendicular. Excuse me, not perpendicular. So in this case, what we have is neither. Okay, this one unfortunately is just the lines are not perpendicular nor parallel, so it's neither. Okay. And notice I'm more comfortable using the opposite reciprocal. Okay, opposite reciprocal, I'm more comfortable with that than using the m1 times m2 equal negative 1, just because of the way I was taught. Okay, last one. You got negative 2, negative 3, and you got 2 and 3, and you have 0, 0, and you have 2, negative 8. Alright, so let's just gonna try it out, see what happens. Slope A is 3 minus a negative 3 over 2 minus a negative 2. That is 6 over 4, which is 3 halves. Okay. Slope B. Slope B, you have negative A minus 0 over 2 minus 0. So this is negative A over 2, which is negative 4. From here, visually, you can tell these are not parallel and not perpendicular. So again, this is another case of neither. Okay, so should be pretty straightforward with a parallel perpendicular line. Watch out, be careful with the slope. Okay, watch out that slope. Okay, Number 5, applications. A business bought the computer for $2,350. It will depreciate over a 5-year period when it will probably be worth $200. Find the average rate of decrease per year. So, average rate of decrease. Right? Okay, so with that, so notice if you make a table, we can say that time and money. Okay, so we know that we start off with $2,350. So that means initially I started out, right? The time is going to be 0. That's going to be $2,350. And 5 years later, it's only $200 left. This is what we're going to use to figure out the average rate of change or average rate of decrease. So slope formula says 2350 minus 200 over 0 minus 5. This is 2150 over negative 5, which means I'm going to use a calculator. I'm not going to do this in my head. This is going to be negative 430. So this means this is negative $430, right? Because if you think about it, this is dollars and this is year. So the average rate of change in this case is going to be, we're losing $430 per 1 year. It decreases by $430 per year. Okay. When it comes to story problems, it is better if you put a label with the slope because you'll make things more meaningful. Okay, it'll make more sense when you're looking back to see exactly what kind of stuff you're solving. Alright, last problem. Mark runs a mechanic shop and charges a fixed amount plus an hourly rate to work on cars. So it looks like we got some kind of time and we have a cost. If 2 hours worth of work costs $143 and 5 hours of work costs $320. Find the hourly rate and the fixed amount. Okay, so let's go ahead and figure out what the hourly rate is. That's just basically our slope. And I'm going to use the 320 minus 143, y2 minus y1, over 5 minus 2. Okay, so calculator says 320 minus 143 is 177 divided by 3. And that gives me 59. Okay. So, which means this is the hourly rate is $59 an hour. Okay. So, now we're going to figure out what the fixed cost is, right? The fixed amount. Let's take the 2 hours and the 143 and let's work ourselves backwards. Right? If I know 1 hour is 59, I'm just going to subtract my way back. 143 minus 59 is 84. Minus another 59, that's going to give me 25. So this right here is my fixed amount. Okay, or fixed cost for the consumer, right? It's kind of like a service fee type deal where they charge you $25 and to look at stuff, and then whatever hour that it goes after that is you add an hourly rate on top of that. So slope. Okay, so this is it for the linear. Should be pretty straightforward. You got any question, drop me a line. You can do it on the forum, right? The discussion forum on Blackboard. You can shoot me an email at whsieh@grcc.edu. Okay, and yeah, right, sounds good. We'll see you guys later.